Hi, and welcome to Python for Predictive Analytics at Gogo. This is session 1, where we'll focus on loading up the Anaconda software package and using Jupyter Notebooks to learn our way around Python and some basic plotting libraries that's contained in Python. So the goal for this first session is just to be able to start our Jupyter Notebook and play around a little bit, and we'll learn how to load those most basic libraries. So after you've downloaded Anaconda, which is under the prerequisites page on session 1, so the session 1 wiki is right here. So under prerequisites, we've already downloaded Anaconda, and we've downloaded our course file, which is session1.zip, and unzipped that as well. So to start Anaconda on a Mac, I'm going to search for the Anaconda Navigator. If you're on a PC, you can search, search for Anaconda Navigator, and we'll open that application up. You can see Anaconda is loading now. Okay, and we'll want to launch Jupyter Notebook. So we'll go ahead and click Launch. And what that's going to do is it's going to open a tab in our browser. And you can see here it's our file browser, and this is our Jupyter Notebook right here. So right now you'll see all of the files on your computer, and you'll want to go to the spot where the location on your system where you downloaded the session1.zip file. In this case, it's in the Downloads area. So I go to Downloads, and somewhere around here I should see session1. Exactly, session1.zip. So here we are. In this directory structure, you'll see two files, session1.ipynb, which stands for IPython Notebook. That's the notebook we're going to be running that contains the Python code that we're going to execute. And this other file, ldpc.csv, this is our CSV data file. Now, we can load in all sorts of different file types. We can load in Excel, and we can even connect directly to SQL tables. But to keep things moving along today, we're just going to use this ldpc.csv file, which is actually an extract from the flight summary tool. So the way to launch this notebook is we'll click on session1.ipynb. So go ahead and click on that. I'll just go back here for a second. Okay, so we've clicked on that, and we've got our first notebook up, and it should look something like this. So what you'll see is that the notebook's comprised of different cells. Cells in our Jupyter Notebook can take a few forms. The two most common cells that we'll encounter are markdown cells and code cells. That just refers to what sort of the type of the cell. So this cell is a markdown cell. You can see when I click on it, up here is labeled as markdown, which means it's just text. There's no code being executed. The way to execute a cell is to hold down Shift and push Enter, and you can see we've run the markdown cell. Here's another markdown cell. As you can see, it's labeled markdown up here. As we go down our cells, another markdown cell. This is a code cell, and you can see when we click on it, this little box up here changes to code. And so here we'll import our first Python library. We'll import sys. So we've imported sys successfully. Here we're going to run our first Python code. For anybody that might not be terribly familiar with Python, we're going to define a string here. We're going to set it equal to hello world. This is the value of our string. Our variable, our object in this case, is my_string, and we'll use a printout statement. And so when we execute this cell by holding Shift Enter, you can see it prints out hello world. So that's the basics of Python. We can also do some string formatting, which you'll see why it can be useful later when we start making plots. Here we can see our string, which we've defined. The name of our string is called myOtherString, and the string itself, the value, is the loneliest number is, and then you'll notice these curly braces. The reason these curly braces are here is to do some formatting. And what I mean by formatting is, well, let's just see. So we've got this formatting statement right here. And what's nice about this is we can pass in all sorts of different values when we want to format it. So let's define another object in Python. We'll call it myInteger. Okay, so we've got myInteger equals 1. And now we're going to print out the formatting. So we're going to say myOtherString.format, and the argument we're going to pass to that is myInteger. So when we execute this cell, it should say the loneliest number is, and then we've passed in this integer value is 1. We could have changed this to 2 or 3. and you can see the printout statement, or 4 rather, and you can see the printout statement changes accordingly. So this will be nice, and you'll see why a little later. So let's go to another markdown cell. This is titled Load Some Data with Pandas. Now Pandas is the Python library for data science, and we're going to be loading in pandas again and again and again. And this is kind of the core. Pandas is one of the core packages or libraries that we're going to need to do data analysis. So again, you can see this is Markdown. We'll execute it. It renders the Markdown. And now we're going to import pandas. And you'll notice we import the library, but we have this other statement back here, which is as PD. This as PD is importing the library and then aliasing it. So now we can refer to our pandas library, and we don't have to type out pandas every time. We can just say PD. We could have. This is nice because it's an abbreviation. We could alias it as anything we want, but to keep it short and sweet, we'll just call it as PD. So you can see we've imported that successfully. You can see the number over here that we've executed it. Now we want to load our data. So we define our file, which is this ldpc.csv file, which is an excerpt from flight summary, and we're going to read it in with this pandas read CSV function. And the way we read it in is pandas read CSV, and we load it into a data structure. And the data structure is called a pandas data frame, and this is kind of the core data structure that we're going to work with again and again and again. The pandas data frame, the way it can be thought of in this case, if you're coming from an Excel background, the way you can think of a data frame is an Excel spreadsheet. If you're coming from a SQL background, the way to think of it is a table. So we'll create this object, our data structure. We're going to call it my_data_frame. We could really call it anything we wanted, and it's equal to PD, and we're reading this CSV. Again, as I mentioned, we don't have to restrict ourselves to just CSV files. We can load in Excel files. Pandas has all sorts of really great functions to read pretty much any file you can imagine. But in this case, to keep things simple, we're just going to use a CSV file. So I'll execute this by holding Shift and pushing Enter. Great, we've read in our file. Now we want to inspect our data frame a little bit to see what we're working with. And so one of the functions we can call in that is mydataframe.info. Now one thing I haven't pointed out to this point is that you'll see that there's a lot of lines in our code cells that start with the pound sign. In Python, the pound sign denotes a comment, so we can make any sort of statement we want. We could say my comment here, and this is just a comment. There's no code that's actually executed. It's just to keep things, just to help to describe what we're doing. And so you can see we're going to print some information about our data frame. So we call it mydataframe.info. What you see here is it says range index. That means we have 144 rows, and you can see here of the columns we have 42 total columns, and here it describes each of the columns. So if you've looked at the flight summary tool before, a lot of these are going to be quite familiar to you. We've got airline, tail, different software versions, LRU versions, availabilities, ping times, you get the idea. And it also gives you the type. If you're coming from an object-oriented programming background, type is obviously very important. We've got integers, we've got floating point numbers. You'll notice that Pandas uses this object type. In this case, it's a string, and this is what Pandas will load in any kind of type that it doesn't automatically identify. And so this just prints out some high-level info. So 144 rows, 42 columns. Those are the dimensions of our data frame. We can also print out just the dimensions of our data frame by calling mydataframe.shape. And you can see it prints out 144 rows by 42 columns. Now, if we want to inspect just the first few rows of our data frame, we can call the head function. And we'll say mydataframe.head, and you'll see it prints out, and it looks very much like an Excel spreadsheet. It prints out the first few rows of our data frame. Now, as you can see, we see all of our columns here. And to save some space, you'll see this ... That's because there's a lot of hidden columns because it doesn't want to render the full 42 column-wide data frame. It just wants to print out like a summary, and that's what this ... summarizes. It's just a summary. If we do want to see all the columns, we can set this option in Pandas. We can call pandas.setOption max display columns. So it's going to display all the columns, and at this time we're going to redefine our data set. We're going to say data equals my data frame. So this is just a second data frame now. That's just a copy of the first, and we're going to look at the first 15 the first 15 rows. So now, as you can see, as I scroll from left to right through our data frame, you can see every single column and the first 15 rows for each of those columns. Again, this looks like just an Excel, a big Excel spreadsheet, and that's a good way of thinking of it. So a little bit about these data frames. The way you can think about them is comprised of rows, columns, and data. The rows, I think, are pretty self-explanatory. The columns as well. The data is what's actually filling in the individual cells. So this would be data, data. You get the idea. Now, what's nice about pandas is we can access individual columns in our data frame, and those are known as, in pandas, those are called series. So I want to access the tail column of my data frame. So I'll call my series, this is a series equals data of tail. And if we want to inspect the type of my series, you can see it's a pandas series. Now, if we want to print out the first, let's say we want to print out the fourth and the fifth the fourth and the fifth rows, we can see there. If we wanted to access just the first 3 rows, we would use this statement, so I can uncomment that. We can try printing this out. So this will access the first 3 rows. You get the idea, and those are our tails for the first 3 rows. Okay, now if we want to access the last 3 rows, we can try this, and we'll encapsulate this with our print statement. So you can see those are the values, the last 3 values for our tail column. Now, the next thing we can do with our data frame is some filtering. So as we inspected our data before, you notice there's all these columns. So among all these columns, and again, they're listed up here, and I encourage you to inspect them for yourself, but one of the columns we have is departure airport. So let's filter our data, and we only want to look at a data frame where the departure airport is equal to Seattle. So let's go ahead and do that. We'll define a new data frame here. We're going to call it data_filtered, and it's equal to only the subset of our original data frame where the departure airport is Seattle. So we've executed it by pushing Shift-Enter, and we've got data filtered. If we want to see our shape, the dimensions of this new filtered data frame, you can see we went from 144 rows down to just 34 rows. And again, the number of columns has remained unchanged. So now, what's nice about these filters is we can apply multiple filters and connect them together. And when we do this, it's important that we encapsulate each filter in smooth parentheses, as you see here. So again, we're going to keep the original requirement that we had, which is the departure airport being equal to Seattle, and our ping availability we're going to ask to be greater than or equal to 96. So now we're going to redefine our data filtered data frame. So forget what it was back here. Now it's being reassigned to this, and then we're going to print the shape. Now we've gone from, by adding in this additional availability requirement that the flight be greater than or equal to 96, now we've reduced our number of rows from 34 down to 42. Now one thing, if any folks listening aren't terribly familiar with flight summary, each row of our data frame, by the way, is a flight. This is the flight ID, the airline, the tail, the software version. You get the idea. All these columns. So each row is a flight. That might be a detail I had omitted originally, so that's important to keep in mind. So where were we? All right, now another nice thing you can do, so again, this is a markdown cell, as you can see up here. So we'll execute it. It renders the markdown. A nice title there. So now we're back to a code cell, and one of the things I wanted to mention that we can do with data frames is we can create new columns in our data frame, and the way we can do that is just like you see here. Here we're adding a couple of strings together. So we're going to create a new column called route. So we're going to say data route. This is what we're deciding to name it. We could call it my route if we wanted, my route. We could call it anything we want, but let's keep it simple and just call it data route, and it'll be equal to the departure airport plus an underscore string, a single character underscore, plus the arrival airport. So now we've got an idea for route, and then after we've defined that in our data frame, we want to print out the first 5 rows, as you can see here. So let's execute that, and you can see it's strung together, the departure airport, the underscore character as we defined up here, and the arrival airport. And again, the type is an object, which in this case we can interpret it as a string. Now we can inspect our data frame again by calling data.info. And you can see now, again, we have 144 entries. And now, if you remember before, we had only 42 columns. Now we have 43. And of course, the 43rd column then is our new column that we just created, which is route. Okay, so if you're coming from a SQL background, you probably are familiar with group bys, and group bys are extremely useful, and you can also do them with pandas data frames, which is really nice. So to introduce you to group bys, we'll go down here and we're going to create a new data frame, and we're going to call it data ag. So what is data ag? Data ag is equal to a subset of our original data frame, which is just the subset of the route and ID columns. We're going to group by route, and the aggregation we're going to use is the count. So what that's going to do is group by route, and it's going to count the flight IDs. So in this way, and importantly, we're going to reset the index so everything looks the same. So we'll go ahead and execute this by holding Shift and pushing Enter, or Return if you have a Mac. Another nice thing, you don't necessarily have to print an object. You can just type the object in and push Shift Enter, and it will print it out. So you can see here, this is the result of our group by. We have our routes. These are all of the routes in our, so not many routes, and you can see the count of flights in each route. So the Austin to JFK route had 18 flights. The Seattle to, I guess that's San Antonio, I think, had 34 flights, and the Salt Lake City to San Francisco had 34 flights. So that's one option that you can do for group bys. Another alternative approach to group by statements is you can do separate aggregations on multiple columns. So again, this is just going to count This approach is just going to apply the count aggregation to all of our columns which aren't route. In this case, let's say we have a few more columns that we want to mess around with. So we're going to redefine our data ag data frame, and it's going to be equal to our original data frame, but with only three columns: route, our flight ID, and RTT average, or average ping time. So this is a data frame that I've highlighted. This is a subset of our original data frame, and we're going to group that subset again by route, but this time we want to apply separate aggregations to our ID column compared to our average ping time column. And again, our average ping time column is RTT average. So if we use this syntax right here, we're applying the count aggregation to our ID column, we're applying the mean or average aggregation to our ping average time. And again, we want to reset the index, which is very important. If you'll notice, anything in Python that's enclosed in this way with curly braces, that's going to be a Python dictionary. If you're not familiar with Python, I encourage you to look up the syntax with how to work with Python dictionaries, but we won't go into that much more for this class. So I'll go ahead and execute our redefined data ag. And so we've defined our data ag, so we can inspect that again. So by pushing data ag. By the way, if you noticed, I added an additional cell by going up here, clicking the plus, which inserts a new cell below, and let's inspect it really quick. So we'll execute this just by pushing Shift Enter, and you can see, we've got our group by results, so our route. We've got the count, which is just like we had before, and now we've got the mean of all of the ping times for the flights on that route. We can do additional things with our data frames like sorting. So we can sort our data frame with these following arguments. And you can see now we've sorted it by ID. And I encourage you, I'm not going to go over in too much detail what the sort values function does, but you can go to the pandas website, which you can find up here, pandas. In fact, I can go to, what we can do is we can search pandas sort values. So we'll actually say pandas sort values. We can find the documentation for that, and you can inspect all of the functions related for that. Okay. Now that we've got our basics down of how to work with a pandas data frame, let's move on to making charts. So Python has some pretty awesome plotting libraries contained within it, and one of the favorites, I would say, my two favorites I'm going to show right here, which are matplotlib and Seaborn. So first let's start with matplotlib. So this is a plotting library in Python, and the first thing we need to do is import it, and we're going to alias it just like we did before, and the alias we're going to give is PLT. The reason we want to do this is because we don't want to type out this whole long thing every single time we need to call something from this library. So we'll alias it just as PLT. We'll hold down Shift and push Enter. Okay, we've imported it. Now we want to make a bar chart. So we'll call plt.bar. We're gonna give it, the arguments we're gonna give it are x, data of ag of route, so that would be this series right here from this data frame, and the y-axis is going to be ID, which is the count of flights in that route. So we'll execute this by holding shift and pushing enter, and you can see it prints out a bar chart, a sorted bar chart, because remember, we sorted our data frame of flights for each route. So you can do a lot more than just bar charts with Matplotlib, and one of my favorite functions is the histogram. And as we get more into machine learning later on, histograms and being able to analyze data using histograms is going to be very important to doing some machine learning and predictive analytics later on. So the first one of the columns in our data frame was GNMS forward link bytes, or just the amount of data as measured by Galat in the forward link. And so let's make a histogram of that. So we'll define a variable. We'll call it my variable equals this. Right now, my variable is just a string. And I added some others in comments here. We could redefine it if you wanted to make histograms of those. But we'll call plot.hist, and we're going to give it the series of data of my variable. Now remember, data is our original data frame that we loaded in, far back here. So data of my variable, which is a series, so that's the data we're passing to it, that entire column, this entire column. We're going to give it a label, and the label we're going to give it is just this, the string. We're going to label the y-axis, which is counts. After all, it's a histogram. And then here's where some of that nice formatting comes in. And so we're going to call histogram of our curly braces for our format, and then we're going to format it with my variable. Now, we could have just typed in GNMS forward link bytes here, but now we only have to type it once. And you can imagine how useful this can be if you're going to loop over a data, like say a list of all of the variables that you want to make, and you can just format it every single time, and you'll have nice automatically formatted histogram labels. So finally, we're going to add some grid lines to our plot, and then we want to show it with plot.show. So I'll execute this cell by holding shift and pushing enter, and you can see we've labeled it and given it the grid and everything just like that. So if we want to change the definition of my variable, we can comment this out, and let's say we want to look at the maximum number of authenticated passengers. That's this column in our data frame. So we'll say my variable equals maximum auth pass. We'll push shift enter and execute it again, and you can see now we've got the distribution of max number of authenticated passengers. So you can see here this count is a count of flights. So you can see 40 flights occurred where the maximum number of authenticated passengers was between 10 and 20. 5 flights occurred where the maximum number of authenticated passengers was between 0 and 10. You get the idea. So we could do this for all sorts of variables. We could comment this one out, and let's say we want to look at the ping availability, for instance. So we'll say my variable equals ping availability. We'll execute this again just by holding shift and pushing enter. And here you can see that most of these flights are very available. These flights aren't very good, but it's good that most of the flights in our data frame have high availability. That's good. That's definitely good for Gogo. Okay, so that's a brief intro on how to make histograms with Matplotlib, but you can also use another function which I think makes much prettier plots, which is a package called Seaborn. Now Seaborn, we're going to use the displot function, so you can click on this here and read all about displot, but basically it's a big wrapper around the original function that we use. So we'll import Seaborn and we'll alias it with SNS just so we don't have to type out Seaborn. Okay, so that's running. Okay, that's been imported. Now we're going to plot 2 histograms on a single axis. So we've got our first set of data, our second set of data. The first set of data, we want to plot the Austin to JFK route versus the Detroit to Tampa route. So we're going to label our data like this, and this, again, if you remember from before, is filtered. So we're filtering the original data frame just on this route, so that's what we're going to call route 1 data. route 2, we're going to filter just on this route. And the things that we want to compare between these two routes is the ping average time. So we're going to create a new variable. I'm just going to label it var. We could call it my variable. Here I call it var, so we'll just stick with that. We're going to specify a number of bins. Now, if you don't specify this number, it will choose a default value, just like we did up here. If you notice, we didn't specify a number of bins up here. It'll choose a default value, and you can figure out what that default value is by reading the documentation. But here we'll specify a value, and the number of bins we want is 10. We can also specify a range. Again, we don't have to. It will choose a sensible range for us, but to make things pretty the first time, we'll choose a sensible range. We'll define our figure, which I'm calling x, our axis, which is ax, is equal to plot.subbox. Now this fig size is going to determine the size of the figure that's printed out to the screen. We want to have grid lines just like we did before, and we're going to call our displot, SNS displot, just like we did. And then finally we want to add a legend. Now having the label here, when you add this label argument, and then call plot.legend, that's what allows this label to show up. So let's see what happens when we execute this cell by holding shift and pushing enter. Now you can see we've plotted two different histograms on the same axis. In blue, we have the Austin to JFK route, which is right here. In orange, we have the Detroit to Tampa route. Now you can see the blue very clearly and the orange very clearly. You'll also notice these lines. These lines are called, with Seaborn, in Seaborn, these are called a KDE, or kernel density estimate. This is basically to give you an idea of what your data might look like if you populated it with an infinite number of entries. Of course, we don't have an infinite number of entries. We just have 144 flights total, and we've got a subset of those just right here. So these KDEs give you an idea of what your data might look like if you were to populate it with an infinite number of counts. But of course, we don't have an infinite number of counts, so we just have this discrete binning. Now you'll notice some orange, which again corresponds to this route, some blue, which corresponds to this route, and questions I get quite often are, is this darker color here? Well, this darker color is just the orange on top of the blue. This way you can see the two distributions kind of on top of each other. So the way to interpret this plot is that the average ping time, or the RTT average time, is much higher, and as well as more spread out for the Detroit to Tampa route. As you can see, there's plenty of flights out here with ping times in the 800 millisecond range, whereas the Austin to JFK route, most of those flights are between 600 and 700 milliseconds, as you can see here. Now you'll notice that the counts, these small numbers, these aren't counts. And that's a good observation. And the reason these aren't counts is because these two distributions are normalized. And what I mean by normalized is, obviously we don't have the same number of counts in each of these routes. In fact, if we look back to this bar chart, in the Detroit to Tampa we only have, I think, about 30. Let's go back here. In the Detroit to Tampa we have 31 flights, whereas in the Austin to JFK we only have 18 flights. So there's different number of counts. And what we want to do is compare, we want to do an apples to apples comparison. And so what this does is this normalizes the integrals of each of the histograms to be the same number. So you can really compare the shapes between the two distributions to see what's different. And what you see is that the Detroit to Tampa route, again, has much higher ping times than the Austin to JFK route. So that's how to make and interpret a histogram. Finally, I want to show you how to do some time series stuff. This can be useful. Less useful for machine learning, but if you want to start doing more data analysis with pandas instead of Excel, this is a nice tool to use. So the first thing we want to make, let's make up the plot I want to make and show you is to plot the ping availability as a function of time, specifically as a function of departure date. So I'll show you how we'll do that. So the first thing we want to do is convert our departure date. Again, this is a column in our data called departure date UTC, and we want to convert it to a date time, and we're going to do it with this pandas function called toDateTime. Again, I'm not going to cover the ins and outs of this this function. You can look it up, but basically this converts it to a date time. Then we're going to take that and we're going to create a new column called date. So date time is going to have the date plus hours, minutes, and seconds. Date is just going to be the single day, and we're going to convert that to a date with this dt.date. So we'll execute this by holding Shift Enter. Okay, great. Now we want to use what we learned before in our group by, and what we want to group by is date. And so we'll take the subset of our original data frame. We only want 2 columns for this because we want to plot availability as a function of day. And so we only need 2 columns, which is date and ping availability, and we're going to group by date. The aggregation we're going to do is the average. So we're looking at the average ping availability per day in our data set. And again, we want to reset the index after our group by. So I'll execute this with Shift-Enter. We can print data ag because we've redefined it now, or alternatively, we don't have to do print. We can just say this. Either way. Now this is the data we're going to plot. So again, we're going to define our figure and our axis up here. And we're going to call ax.plot. This is the matplotlib function that we're going to plot. The x argument, of course, is the date. The y argument is the ping availability. And we want to show a grid there so we can better read it. So I'll hold this and push Shift-Enter. See a little bit of a warning sign there. We could add labels to this as I showed you before, but this should suffice for now. So as you can see here, this is our average ping availability on each day in our data set. And you can see our data set only spans from December 6th to about December 13th, so just about a week. And this is a way to make plots, time series plot or a scatter plot with matplotlib. So thank you for following along, and I encourage you to reach out to me on Slack or via email. My username is cmueller, so cmueller at Slack, and join the Python for Data Analysis Slack group. All right, thanks for tuning in.